So let's take a look at what I have here. This is the result. The sim is not very interesting. It's an older version of the setup, and I wanted to use this one to show what we can get once we start adding the temperature field. And the setup is very simple. It's very similar to what I've done. The only thing I've done is I exported the frequency to the upper level. I can remember if I've done this, and then inside the VOP, I have 3 different noises that are driven from that frequency. And then this is the frequency, and then I'm multiplying the frequency by 0.2 and using that with the turbulent with one noise, using it with -1, multiplying it by -0.5 and using it with another turbulence, and then the original value, and all these gets added together, and then that multiplies the force that we've previously created, which is the temp val, which is the gradient normalized, and then I don't know why I have 2 normalization there, but shouldn't matter, and then the dot product between the temperature between the gradient and the velocity, and that result is also added. So it's pretty simple, very similar to what we've done, and we're going to start changing a few things to add the temperature. Now let's say I don't have, actually let me put a null here, and I want to disconnect something. I want to disconnect this whole graph here. I have dissipate node to just slowly diffuse and dissipate the temperature, the density, and I also have in the smoke solver, I have buoyancy set to 1 and cooling rate set to 0.8, which is pretty high. And I'm gonna run the sim. Let me lower the resolution 4 times approximately, and let me turn on caching. Cool, so let's hit play. Okay, we have our simple sim. This is the default behavior, and what I'm going to do simply, I'm going to take the temperature, the density field, and plug it into the temperature field. I'm going to do that using a gas calculate. So I'm going to put down a gas calculate node, and the destination is temperature, and I want to copy the density into that, and I'm going to leave the method to copy instead of add. This is the best way to combine the temperature, and I'm going to leave everything as it is. Okay, let's hit play, and now we have fire added, and as you can see, everything is behaving as expected, and we're currently copying 100% the density field into the temperature. And this is great, because what we can do is once we start adding, let me add our magic network, and let me connect this at the end. Once we start adding details to the density field, the temperature field will automatically inherit all of that stuff. And this is very powerful, because if we get details in the density field, that means we get details in the temperature field. Now let me increase the resolution a bit just to show. And this is what we're going to be doing. We're going to be copying density from the sim and injecting it into the temperature. Now, what is a valid information that we can use as a fire? That is the creative part that we have to think about. And what I've been doing primarily is taking the velocity field and computing the magnitude of it. So and then compute the length of the velocity, and based on the speed, I copy the fastest moving part into the temperature. This is one thing. And what this gives me is, whenever I have smoke that is fast moving, I get temperature there. And this is very realistic, because if you have part from the sim and that is very disconnected from the source, and it starts moving really fast, you will get fire there automatically. You don't have to have anything special to get the fire that you need. And with this technique, if you have a fast moving any fast-moving part of the sim will get picked up by the temperature and gets used. Now, what this creates, when we copy data, let's say we have velocity, we compute the length, and we isolate certain range from there, and then copy that into the temperature. The temperature is not gonna, it's gonna change the sim. The temperature is gonna change the sim. So what's gonna happen is we're gonna see a different behavior for the sim. For example, if we copy the velocity, part of the velocity length into the temperature and have a high buoyancy, it's going to cause the smoke to go up. And if we have a super high buoyancy, it's going to cause the smoke to go up really, really fast. And then the velocity will update to pick up those new edges because now the smoke is going upward. And that information is going to go back into the temperature. So there is this very smart loop that we're going to get for free by just taking two fields that interact with each other and injecting them. And this interaction is very realistic, and it's really hard to get. Let me see if I can find the video super quick. Let me pause. I'll come back while this is simming and finding the video. So for example, here I have the sim, which is this is a little bit more advanced, and we're gonna finish by creating this, hopefully by after adding all the features. But you can see with this idea, see that boiling in the interior part, we're getting that because the smoke is moving really fast, and then that information is isolated based on the velocity and copied, and you get these nice expansion. And let me go back to the beginning. See here, it took a few seconds for it to do that bubbling and started going up. That's because the temperature is getting added over and over, and then once it hit certain points, it caused the smoke to go up really fast, which then made the velocity change and inject back some of that data. So we're going to get a lot of interesting behavior like this. And this is the example that we're going to be creating now. You can see how we're injecting data. See that expansion there? That's coming from this idea. So let me play this at a higher resolution or show it just frame. So let me put down a volume visualization node. And then under the temperature, under here, sorry, this guy. Hopefully I imported the temperature. No. So I'm going to connect the temperature. Let's set this to 1. And I also like to put it here as well for the display field and copy these two guys. Paste it here, and let's use the black body preset and we'll fix it. So let's find a good range, 0 to 10. Let's increase the density a bit. Cool. And let's wait for it. Let's increase the shadow. I'm trying to capture the details more. And again, we're just doing a straight A over B. We're just copying the density, which is not very realistic, but you can see already we're getting a lot of details in the temperature field, and it's decaying properly, and that's simply because of the smoke cooling rate, the temperature cooling rate. Now let me go back and reset this. And now instead of doing this guy, okay, I'm gonna actually delete that. We're going to do something else. So let's dive inside this gas field VOP. And first of all, we need to create a new field that we to temporarily plug in the data in it. Let me delete this guy. So I'm gonna create a gas field VOP. Sorry, I'm gonna create a gas match field node, and I'm gonna call it custom temp. I'm going to reference the density field because it's a scalar, and that's what I want to use. And now I'm going to take the velocity, which is here, and I'm going to compute the length of the velocity. And the length can go from 0 to x, so for now I'm going to put a fit range and expose the min and max, and we'll have to tweak that by hand. And all I'm going to do is I'm going to bind export this data into that custom temperature, into the custom temp field that we created. But from experience, what I noticed, sometimes with this technique, you get a leading edge where the temperature is ahead of the density, and to get around that, to fix that edge issue, I'm going to always multiply the density, the temperature, or any custom field before I inject it with the density. And this will also help vary it according to the density. So if we have a super bright area, it's not going to show up in the super transparent areas. It's going to show properly in the dense area. You don't want the super transparent parts to have very high temperature, because that's not realistic. There is no actual physical material for them to be there. So this idea generally helps, and yeah, you can trust me with this. And let's multiply the density, which is, I don't have it, so I'm gonna bind import the density. Okay, and let's bind export this guy as the custom temp. Cool. Now let's add the gas advect for this field. And let's add the gas calculate for this guy. And let me add a merge here to keep it clean. And I'm gonna change the method to copy, and here temperature, we're gonna inject the custom temp, and let's leave everything as the default, and then let's clear that field for consistency. Sorry. And I want to clear the custom temp. Okay, let's reduce this and see what we have. You can see the leading edge already effect happening there. So we may have to do another multiplication in the render. It shouldn't be happening. Let me double check. Let me import the volume global instead, just to make sure I'm getting the proper temperature. Sorry, the proper density. And we'll still have to tweak the min and max for the velocity. So let me rename these guys. Min velocity. And max. And let's change this to 0 to 10. And let's go back and hit play. Cool. So you can see now, by just doing that, we're injecting temperature at the leading part, where the fastest moving part. And again, if anything is going to be affected or hit or caused to be moved by even another object, it's going to get temperature. Now, whether you want that effect or not is something up to you, but for now we're going to have that behavior always there. So let's increase the buoyancy. Let's set it to 10 now that we have some temperature. Cool, and it's started to go up. And you see, this is very natural, because the fast moving parts will always be hot and the slow moving part will always be cold. And if a part is moving really fast, it also gets temperature. And you can see by just doing this idea, we're starting to get a lot more interesting details within the sim. You can see the mushroom effect. The interesting mushroom effect, not the boring mushroom. So let's change this. And what I like to do, what can happen in this case is, because the temperature is always receiving a value from the sim, and that, for example, let's say we capture a certain part of the sim, we inject that, we take the velocity, we inject that back into the sim, which will cause it to rise faster. Now the next frame, because it's rising faster, the velocity is also bigger, and we're going to take a bigger chunk, bigger section of that velocity and inject it back into the temperature, which will cause it to rise even more. And that can create a loop where the sim is going to keep rising forever, and it may also explode because there is no limit for what can happen to it. And the easiest way to fix that is inside the is using a gas field VOP. So I'm going to create a gas field VOP, and all the way after everything, after we process everything, I'm going to import the temperature, and clamp it. That's it. I'm going to clamp it between 0 to 100, which is pretty high number, and then bind export that as the temperature. And this will be like a safe lock on the temperature from on the sim from expanding, from exploding. Cool. So let me lower this to 2. And what the temperature diffusion is doing is basically it's blurring that temperature field. We can set this to 0 if we want to. Actually, set that to 0. We're not going to see a huge effect because 0.1 is not really that much, but I like to set it to 0.1 or maybe 0.2 in some cases, just to get those weak temperature areas to have softer dissipation. And that's why I set it to 0.1 in most of the cases. And then the cooling rate, the reason this is high, it really depends on the data you have in the sim. The higher the cooling rate, the faster it's going to decay the temperature, and which will cause the sim to slow down quickly. But if you want something more energetic, you can have the temperature really high in terms of values, and then you can have a strong cooling rate, so you have a lot of burst within the sim itself. So I think that's pretty much it for this video. I'm going to increase the resolution a bit and then make sure that I have the proper settings. Cool. I'm gonna run a sim here, and then we'll continue in the next video. Thank you guys for watching, and see you in the next one. Bye bye.